Okay, so today we are going to be discussing real numbers. So our goal today is to define the real number set and its properties. So you'll see here we have a Venn diagram, and in this Venn diagram you have the natural numbers, which is the smallest set, which falls completely into the whole number set, which falls completely within the integer set, which falls completely within the rational numbers. You'll notice that all of these sets make up the real numbers, but you might ask, well, why didn't I mention irrational? The rational and irrational are divided by a line. There is no overlap between these two sets. There is that line that divides it. So if it falls under irrational, it will not be a rational number, and vice versa. So starting with the smallest set, those are your natural numbers, how you would naturally count. So if we told a 5-year-old to count, they would count 1, 2, 3, 4, 5, and they would keep going. So that is their natural numbers. I remember it because naturally that's how you count. Once we get into the whole numbers, I, for whatever reason, think about a hole, like if someone were to dig a hole in the ground, or if there was a hole in a piece of paper or whatever. For some reason, whenever I picture a hole, I always picture it to be a circle. And the number that is a shape of a circle is a 0. So when you're talking about whole numbers, we're going to be talking about those counting numbers, and then in addition to that, 0. When we move into integers, now we're going to add the negative counting numbers as well. So these are all your counting numbers, 1, 2, 3, and we can go negative, negative 1, negative 2, negative 3, and then the 0 there in between. So typically that's how you would draw out a number line and label. Those are the numbers you would typically put on your number line. Rational numbers are numbers that can be written as fractions. So for instance, you might have 1/2.
Hey, sweets.
So rational numbers would be numbers such as 1/2, 3/4. We can also put -2 in there, because if I wanted to, I could write that as -2/1. It's written as a fraction. You don't have to write it as a fraction, but you can write it as a fraction. And that's what the rational numbers say, is that you can write it as a fraction. You also have decimals that repeat. So like 0.7 repeating, that is, any decimal that repeats actually can be written as a fraction. And for instance, this one can be written as 7/9. If I wrote a decimal that ends 0.76, that is the hundredths place. So that's 76 out of 100 is how I would write that. So rational numbers, even if they're not written as a fraction, they might still be a rational number if they are a decimal that repeats or a decimal that ends. If I had 0.123, that's to the thousandth place, so I have 123 out of 1,000. So then what are these irrational numbers? Irrational is the opposite of rational. So if rational is they can be written as a fraction, irrational is going to be that they cannot be written as a fraction. So things like the square root of 7 or the square root of 3. If you were to punch those into our calculator, this one comes up as 1.732 ... They're decimals that don't end. They're not nice numbers. We have pi. Pi is something you guys learned, you guys learned it probably a while back, but last year in geometry you used this quite a bit. Pi. It has a value of 3.14159265. It keeps going on forever and ever and ever. There's another value. It's e. That's another constant. It's kind of similar to pi, but we won't get into that value and that number this year. But the value of it is 2.718 ... because that, like I said, just keeps going on forever and ever and ever. Okay, so moving down to actually defining these terms. Natural numbers, we could call those counting numbers. These are counting numbers, and there is a symbol that we use to represent natural numbers, and it's actually a capital N with an additional line there. When we're talking about whole numbers, we'll refer to those as counting numbers and 0, and this symbol is going to be a W with an additional line there. Oh, looks a little funky. There we go. Integers are going to be positive and negative counting numbers along with 0. So like we said, natural numbers is going to be the smallest, and then you keep adding numbers to these sets as we move down the list or out within our Venn diagram. So So there's our definition. And then we also have the symbol here is a Z for integers. And the Z has that additional line. So that is a Z. Rational numbers are going to be the numbers that can be written as a fraction. All right, so these are numbers that can be written as a fraction. And actually the symbol on this one is a Q with that line there. It might help if you think about it as a quotient. Quotient are division problems, or fractions. So quotients, that's where the Q comes from. So rational numbers are numbers that can be written as fractions. And then we'll go to the irrational numbers, which are the opposite of rational, which means that they are numbers that cannot be written as a fraction. Now, irrational numbers, we don't have a good symbol. There are a couple different symbols that people use, so for that, we'll just write out irrational when we're talking about irrational numbers. All right, so one of the examples that you're going to be asked to do on this first assignment is to graph number locations on a number line. So there are three numbers, -3 halves, 1.777, and the square root of 5. It might be easier if you actually put this into a calculator so you actually can kind of see the decimal value of these. So if you type -3 divided by 2, because -3 halves is -3 divided by 2, the value of this is -1.5. So that value is going to fall in between -1 and -2. And you want to make sure you put it, is it closer to 1 or closer to -1 or closer to -2? And in this case, we're going to be smack dab in the middle. So, and make sure when you label it on your number line itself, you're labeling the number that it gave you. So we're going to label this as -3 halves here, not -1.5, because they gave us -3 halves. So that's what we have to put on our number line. The 1.777, that's going to be in between 1 and 2. That one's going to be closer to 2. So here it is, that's 1.777. And I can even put that there. That is 1 7/9 actually. The square root of 5, I can type that in my calculator. And when I do, I get approximately 2.236. So that's going to be in between 2 and 3, closer to the 2, and I'm going to mark that as square root of 5. Okay, so when you're marking things on the number line, you want to identify between what two numbers is it and to which one does it fall closer to. So when you are creating this number line on your assignment, if the numbers are there, awesome. But if you have to put numbers in, I should see relatively where 0 is. Okay, so are we working on the left side of 0 or on the right side of 0? And make sure you are putting in the two numbers that it falls between. So it falls between 2 and 3. I want to make sure I can see 2 and 3 on my number line. If it's falling between 7 and 8, make sure you can see 7 and 8 on your number line. The opposite or additive inverse of any number is when the sign changes. So for instance, if I'm talking about A, the opposite's going to be -A. Okay, so if I was talking about 4, changing the sign would be -4. If I was talking about -10, the opposite would be +10. So you're going to change the sign when we're talking about the opposite or the additive inverse. Okay. The reciprocal, which is also the same thing as the multiplicative inverse of any number, is if I had the fraction A over B, then the reciprocal is B over A. If your original is not a fraction, write it as a fraction, so put it over 1 so you can view what it will look like as a fraction. Okay. So we have an example here. It's the opposite of 3/5. So opposite means to change the sign. So the opposite would be -3/5. Okay. Moving on, we found the opposite. Now it wants to find the reciprocal. So the reciprocal is flipping the fraction. So it was 3 over 5. Now it's going to be 5 over 3. Okay. If I gave you another number such as, let's say I said 2 3/4. The opposite is pretty easy because you just make it negative. 2 3/4. Okay, but the reciprocal is going to be a little bit difficult because it's not written as a fraction. Right now it's written, well, it has a fraction as part of it, but it's written as a mixed number. So we need to write this as an improper fraction. And so 2 3/4 as a mixed number, you would do 4 times 2 is 8. 8, add 3. So 4 times 2 plus the 3. So 4 times 2 is 8. 9, 10, 11 fourths is what we have here. So you have to write it as an improper fraction. Then you'll be able to flip it to say the reciprocal then is 4/11. Because otherwise, the mixed number, you can't write the reciprocal for it. Okay, so the closure property, all that says is that if you're dealing with real numbers and you add them, your answer is still going to be a real number. And if you're dealing with real numbers and you multiply them, then your answer is still going to be a real number. So here we have a real number plus a real number. Your answer has to be a real number. A real number times a real number, your answer is a real number. And I should also put on here that A is a real number and B is a real number. Okay, so A and B are real numbers when we're talking about this. Okay, so for this next one, the commutative means that you can change the order. If you add two real numbers together, it doesn't matter if you have A and you add it to B or B and add it to A. Order is not going to matter with addition, and it's not going to matter with multiplication. When you're adding or multiplying real numbers, order will not matter. For this next property, the associative property, it just means that if you're adding three numbers together, you're adding three real numbers together, you can add the first two together and then add the third one, or you can add the second to the third and then take the first and add it to that answer. It doesn't matter which two you group together first and add, as long as you're adding the three numbers. And the same thing will work for multiplication. You can take the second two, multiply them, and then take that first one and multiply it by it. Or you can multiply the first two and then take that answer and multiply by that third number. It does not matter. All right, so the identity property just says that with adding, when you add 0, your number doesn't change. And when multiplying, if you multiply by 1, this is still going to equal A. It does not change. Okay, so by multiplying by 1, that's your identity. The number is still going to be what it originally was, along with adding 0. Those do not change a real number. The inverse is going to be how do you undo something to get back to the identity. So if you start with A, with the adding, you would have to add the opposite of it. So you'd have to add negative A to get back to 0. So you would have A, add the opposite of it to get back to that identity of 0. When you are multiplying, that inverse property would be by multiplying by the reciprocal. So this is A over 1 technically, so the reciprocal of it would be 1 over A. So if you have A, you multiply by the reciprocal, that will get you back to the identity, which is just 1. Okay, so that's the inverse, is to undo something. Distributive property, many of you guys probably will recognize this. This is if you have A, and this doesn't fall under addition or multiplication, and you have two numbers that you're adding together on the inside of parentheses. This would be the same thing as taking A times B plus A times C, where you are distributing the A to both the terms on the inside of those parentheses. So we have examples here of which one is illustrated. You do have to make sure you're specifying if it's additive or multiplicative. So in that first one, it is 6 plus an opposite, and it equals 0. So if we take and we look and say, okay, so I can see that addition is happening here. Which one actually equals 0? So you're just lining it up. Does it look like this property here that's set equal to 0? And I have a number plus its opposite, a number plus the opposite. Looks just like this, so we call that the additive inverse. So this is the additive inverse property. Okay. The next one, we look at it and So we have parentheses and then no longer have parentheses. There's none that get rid of parentheses. So that means something happened within this set of parentheses. Negative 4 times 1 became just negative 4. In this location, it's still right here, but negative 4 times 1 is negative 4. So something that's being multiplied by 1 that no longer has 1. So it's multiplication, multiplying by 1. This is the only one that has multiplied by 1, and it's still that same number. So we had negative 4 times 1 equals negative 4. The negative 4 would be the A, so that shows up both times. So for B, we're looking at the identity property with multiplication. So we call that the multiplicative identity property. All right, so let's take a look at the next one. Again, this one has parentheses and then they're gone. So what's happening in there is we're doing 3 plus 0 and it's turning to just 3. Okay, so it's addition this time, it's not multiplication. So it's on this side. Something plus 0 is equal to 3. Something plus 0 is equal to that something. So that again is the identity property, but this one is addition, so the additive identity property. All right, let's see if we can figure out the last one. The last one, this one has 2 sets of parentheses, the negative 3 and then grouping them. This one also only has 2 sets of parentheses. It's grouping the first 2 and it's grouping the negative 3 together. So actually, nothing's changed there because they both have parentheses, so it's not necessarily that. But where the parentheses are have changed. So we were grouping 2 and negative 3 together, whereas we're moving it to the negative 5 and 2. So when parentheses change their location, plus what do we have going on here? Addition? Yep, addition. So we're on this side. Parentheses are just moving. We call that the associative property. So this one's going to be the additive associative property. And that's all I have for you.